Hello folks, today we're going to do section 9.3, Similar Polygons. As usual, the homework is up here. Now, my first question is, are these two rectangles similar to each other? So the first rectangle, the bigger one outside and the smaller one inside. Are they similar to each other? Think about it or take a guess. Now, because the question tells you already that there are two rectangles, so we know for sure that the four corners are 90 degrees. So, from the previous lessons, we know similar figures have the corresponding angles for similar figures are the same, and the corresponding sides of similar figures are proportional. So now, the corresponding angles, they're all 90 degrees, so they're the same. That satisfies the condition. What about corresponding sides? We'll need to check, okay? So let's see. We'll do these two first. 20 divided by 18, that is equal to 1.11, repeating. And then let's do 10 over 8. Well, 10 over 8 is equal to 1.25. Are these two ratios the same? No, right? No, they're not the same. So these two rectangles are not similar to each other. So what can we conclude from this example here? Well, for two polygons to be similar, both of the conditions must be satisfied. Okay, so their corresponding angles must be equal and their corresponding sides must be proportional. Both must be satisfied for two polygons to be similar. Okay, and again, polygon is a many-sided figure. You can see page 315 and 316 to see different types of polygons. Now, let's do an example here. Example 1. Are these two polygons similar? How do you know? Well, we know from here that if they are similar, then these two conditions must be satisfied. So let's check each of the conditions. Okay, so first condition, corresponding angles. Corresponding angles, we have angle M and angle M prime. Angle M is 90 degrees and angle M prime is also 90 degrees. Angle H is equal to angle H prime. Angle A is equal to angle A prime. Angle T is equal to angle T prime. So all of the four angles are equal to each other. Well, the corresponding angles are equal to each other. So this is the first condition, satisfied. Now, second condition is corresponding sides are proportional. So let's find out if that's true. So let's do the bigger side, bigger shape, bigger polygon over the smaller polygon. So the first one we have, let's do MA over M prime A prime. Okay, so that's equal to, oh, whoops, we'll do bigger over smaller. So that's, sorry, that would be M prime A prime over MA. So that's 1.54 over 1.1, which is equal to 1.4. So let's try the second one. A prime T prime over AT. So that's 4.9 over 3.5, also 1.4. We'll check all the sides, okay? So third one, we can do M prime H prime over MH. That's 4.2 over 3, again 1.4. And the last one, ht over h prime t prime over ht. So that's 2.1 over 1.5. That's equal to 1.4. Okay, so first condition satisfied, second condition satisfied, which means that the two polygons, they are similar. And you can explain that the corresponding angles are equal and the corresponding sides are proportional because all the ratios are the same. Okay, next example, that looks a little bit different. Let's maybe label them first. Let's do A, B, C, D, just so it's easier for us to name the sides. A, B, C, D, E, F, G, H. Okay, so the question tells you that the two polygons are similar already. So we don't need to prove their similarity first. What we can do is we can just directly find out the ratio and then find the missing term. So let's make this missing term x and make this missing term y. Okay, now let's see. So this polygon A, B, C, D is similar to the polygon E, F, G, H. But let's write the letters correspondingly. Okay, so A, the corresponding letter or the corresponding angle will be, which one? Will be this one here, G. Yes, will be G. Oops. And then B, the corresponding angle will be H. And then C is this one here, will be E. And D then, of course, is going to be F. Okay, so what do we know? We know the corresponding sides are proportional, and we want to find the missing sides. So let's write down the four fractions first. Well, AD will be proportional to AD and GF will be proportional to DC and FE, and then BC will be proportional to HE, and AB will be proportional to GH. Well, I know it's a little bit hard to read the diagram like this, but if you can draw this and rotate it, you will see that these two are the same shape. It's just that they are in a different orientation and the sides are a little different. Okay, so let's put what do we know down. We know AD is X. We know GF is 21. We know DC is 35 and FE is Y. We know BC is 30 and HE is 18. We know AB is 30 and GH is 18 as well. Okay, so Do you guys remember proportion from Math 8? We can use proportions to solve for the unknowns here. Now, obviously, we cannot have two unknowns in one proportion. So what we can do here is we can take out the first fraction and we use something we know already. So it's 30 over 18. We know 30 over 18 is equal to x over 21 because all of these fractions are equal to each other. Okay, and so this is a proportion. And how do we solve for a proportion? We can do cross multiply. So 18 times x is equal to 21 times 30. So 21 times 30 is equal to 630. So 18x is equal to 630. And to find out what x is equal to, we can divide both sides by 18. And so x is equal to 35. So that's what x is equal to, and we found x using the proportion. And we can do the same for y. Y is 35 over y in this fraction, and it's also equal to 30 over 18. And if we do cross multiply, 30y is equal to 18 times 35. So 30y is equal to then 630 as well. So divide both sides by 30. We'll get that y is equal to 21. Okay? And yeah, so that's it for today's lesson. Our final answer is x equal to 35 and y equal to 21. So the most important takeaway from this lesson is that to check or to prove if two polygons are similar, both of these conditions must be satisfied. Okay? If you only satisfy one condition, then you don't know it for sure whether they are similar or not. Just like the first example we did here. Although all of the corresponding angles are equal, but they're not similar to each other. Okay?